Welcome in exploring mathematical patterns in nature. In this video, we'll embark on a captivating journey to discover the fascinating relationship between mathematics and the patterns found in the natural world. From the delicate petals of flowers to the vastness of spiral galaxies, patterns in nature are abundant and often hold hidden mathematical secrets. Join us as we delve into the wonders of nature and explore how mathematics helps us unravel the mysteries and appreciate the beauty of its patterns. Get ready to be amazed by the intricate connections between mathematics and the natural world around us. Let's begin our explorations of mathematical patterns in nature.
Fibonacci sequence in flower petals.
A Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones. This sequence is discovered by the Italian mathematician Leonardo Fibonacci in the 13th century. He is a fascinating mathematician, scientist, and artist throughout the history due to its intriguing patterns and its connection to the natural world. One of the fascinating relationships between the Fibonacci sequence and the natural world can be observed in the arrangement of petals in sunflowers. If you count the number of spirals formed from the petals in a sunflower, you will often find that the number of spirals is a Fibonacci number. For example, some sunflowers have 21 spirals in one direction and 34 spirals in the opposite direction, both of which are Fibonacci numbers. This phenomenon can also be observed in other flowers, pine cones, and even the branching of trees. Therefore, Fibonacci sequence showcases the beauty of mathematics and its connection to the natural world. Moreover, mathematics has immense relevance in the modern world, shaping technology, finance, data analysis, cybersecurity, and scientific research. Its applications are far-reaching, contributing to the advancements and innovations that improve our lives and drive progress in various fields.
Spiral patterns in shell.
Most spiral designs found in shells, such as those Nautilus's or snails. There are also logarithmic spiral. The size of each loop in this spiral rises by constant factor as you move away from the center. According to a mathematical formula, the shell can expand through these designs without losing its structural integrity or shape.
Waves pattern in nature.
Waves have mathematical properties including frequency, wavelength, amplitude, period, and phase. The first is frequency, which is the quantity of full wave cycles that take place in a given amount of time. The second term is wavelength, which is the separation between two successive in-phase points in a wave. Thirdly, a wave's amplitude is defined as the greatest deviation a point on the wave can make from its equilibrium position. It is a representation of the wave's strength or intensity. The fourth is a wave's period, which is the amount of time a wave takes to pass a specific point after going through one full cycle. It is expressed in seconds and is the reciprocal of the frequency. The final concept is phase, which shows where a point is in a wave cycle in relation to a reference point. It is frequently expressed in degrees or radians. These characteristics are essential to comprehending wave behavior.
Spiral galaxies.
Spiral galaxies are fascinating astronomical objects that are also studied mathematically. In mathematics, the study of spiral galaxies often involves concepts related to geometry, trigonometry, and even calculus. In the context of spiral galaxies, mathematicians and astronomers use these mathematical representations to study the structure, density, and motion of stars and gas within the galaxy. By analyzing the spiral arms of a galaxy mathematically, Scientists can gain insights into the dynamics of the galaxy and its evolution over time. Understanding spiral galaxies from a mathematical perspective not only helps in modeling their behavior, but also provides a deeper appreciation for the intricate patterns and structures found in the universe.
Symmetry in snowflakes.
Symmetry in snowflakes are incredibly fascinating because they show us how math is at work in nature. Have you ever noticed how snowflakes have a beautiful hexagonal shape? This is because they follow a mathematical principle called radial symmetry. This means that if you were to rotate a snowflake around its center, it would look the same from any angle. But it doesn't stop there. Snowflakes also have something called fractal geometry. Fractals are self-replicating patterns that repeat themselves at different scales. So if you were to zoom in on a snowflake, you would see smaller versions of the same patterns. And if you zoom in even more, you would see even smaller versions and so on. It's like a never-ending pattern that keeps repeating itself. This connection between math and snowflakes show us how mathematical concepts like symmetry and fractals exist not just in textbooks, but also in the everyday world around us. It's pretty amazing to think about how nature follows these mathematical rules, isn't it?
Fractals in trees.
A binary fractal tree is defined recursively by symmetric binary branching. The trunk of lengths once splits into two branches of length, each making an angle with the direction of the trunk. Both of these branches divides into two branches of length, each making an angle with the direction of its parent branch. In conclusion, the intricate patterns found in nature are not just random occurrences, but are often governed by mathematical principles. From the Fibonacci sequence in flower petals to the fractal of trees, mathematics provide a lens through which we can understand and appreciate the beauty and complexity of the natural world. By studying these patterns and applying mathematical concepts, we gain a valuable insight into the underlying structure of nature. As you go about your day, take a moment to observe the patterns around you and the petals of flower or the branches of tree. Mathematics is not just a subject in textbooks. It is a language that helps us decode the mysteries of the world we live in. Embrace the wonder of nature's patterns and the power of mathematics to unveil its secrets. Let's continue to explore, learn, and marvel at the fascinating relationship between mathematics and the patterns in nature.